Good afternoon, guys. So you have officially learned 4 different methods of solving quadratics. We have talked about the quadratic formula, taking square roots, graphing, and factoring. So now that you have all that knowledge, and hopefully you haven't forgotten it, I'm sure you haven't because you're all lovely students and you remember everything that I tell you, we're going to talk about what you can actually do with solving quadratics. Why is it important that I know how to do that? And one of the big reasons it's important is because it lets me answer questions about objects in motion. Okay? It also allows me to answer questions about profit, but we probably won't get to that today. So our first scenario here, we're talking about a golf ball. Now, if you wanted to, you can go out and hit a golf ball, and there is software that allows you to figure out how high in the air it goes and how long it takes it to hit the ground, all that good stuff. But if you're like me and you suck at golf and you're doing good if you get anywhere within a half mile of the golf hole, I don't even know what that's called. Maybe I think it's got a flag in it. So if you get within a half mile of the flag, you're doing pretty good. Then it's probably going to be a lot easier if you take someone else's data and use that to calculate the height of their golf ball to kind of get a feel for how this is going to go. And that's what we're going to do today. So they have given us an equation that models a golf ball traveling through the air. Okay? So they tell us a golf ball hit from the ground with an initial upward velocity of 128 feet per second. This can be represented by that equation that they give me. Now I'm going to pause right here just to talk about the letters they're using. They're using the letters H and T, and I want you to think about why that would be. If I'm hitting a golf ball, there's probably two things I'm concerned with. Number one is how high did it go? Number two, how long was it in the air? So H stands for height. The reason you've got a T in parentheses right here, what that means is they're telling you the height depends on whatever's in parentheses. So in this case, the height depends on how long your ball is in the air, which makes sense. Because if the ball has been in the air for 5 or 6 seconds, it's probably coming back down towards the ground. It's not as high in the air as it might have been, say, at 2 seconds when it was at its peak. Okay? So that's what they're telling you there. The other thing I want you to notice, think about the y-axis on a graph. It goes up and down. Well, if I'm measuring height, height should go up and down. So in this case, and I'm going to make myself a little note, I would suggest you do the same. Height is always going to be represented by y. So I'm going to put a little y underneath the letter H. Time is always going to be represented by x. And again, that is simply because height goes up and down, and so does y. So now, if I wanted to go answer question 1, it says, when does the ball hit the ground? Okay? Well, think about it this way. If the ball is sitting on the ground, what's its height? Hopefully you said 0. If the ball is sitting on the ground, it's not up in the air at all. So what they are asking me is, when is y, or when is the height, equal to 0? So when is this equation equal to 0? Well, there's lots of ways I can solve that. I could do the quadratic formula. At least to a certain extent, I could factor that. But the easiest way for me to solve this equation is simply to go to my graphing calculator. Okay? And find where that equation intersects 0. So in y1, and you may have to clear some things out just like I do, in y1, all I'm typing is everything right here, this whole expression. So negative 16 x squared plus 128x. And I want to know, when does that equation equal 0? So I put 0 in the second line, and then I go look at the graph. So hopefully yours looks like mine. I can see that it intersects in 2 different places, and I want both of those intersections. So I go to second trace. I choose intersect. I'm going to get the one on the left first. If you want to get the one on the right first, that's fine. Enter, enter, enter. The first time that ball is on the ground is at 0 seconds, which makes sense because that's when it's sitting on the tee on the ground and I haven't even hit it yet. Okay? Then I go back to second trace, intersect. This time I'm going to get the intersection point on the right, which is when the ball's coming back down and hits the ground. And there we go. You can almost see it. There it is. So the second time that that equation intersects 0, or the second time that the ball is on the ground, is after 8 seconds. So we've got two answers here. And I want you to think about which one of them actually answers the question. They asked me, when does the ball hit the ground? Well, the ball hasn't really hit the ground if it's just sitting there before I hit it off the tee. It's this second answer, 8 seconds, that represents when the ball has come back down and hit the ground. So even though, yes, this equation intersects 0 twice, it's the second one that represents when the ball has come back down, so your answer in this case would just be 8. So something to keep in mind with word problems, even though, yes, they're still going to have two answers because they're a quadratic, you may only actually need one of them. That's where you've got to pay attention to the context of the question. So let's say I go look at part 2 of example A. This time they say, at what times is the ball 35 feet in the air? Very similar question. The only thing is now the height's not 0. The height is 35 feet. So the only thing that's going to change, now in my second line in my calculator, I'm not worried about where it equals 0. I want to know, where does that expression equal 35? And again, 35 is a height, so I'm hitting the y equals button on my calculator. Y always represents height. Okay? So I go into my calculator. I don't have to retype that whole equation in the first line. All I have to do is change 0 to 35, and then go look at my graph. And if your screen looks anything like mine, you may have to zoom out a little, and that's okay. So you'll go to Zoom, pick number 3, and then click Enter. And now I can see my two intersections. So let's go grab those. Second, trace, intersect. I'm going to get the one on the left here. Enter, enter, enter. And so the first time that that ball is 35 feet in the air is after about 0.28 seconds. So that's when it's going up. But if you think about it, that ball is going to peak and then come back down. So there is a very good chance that it's going to be at 35 feet in the air at some point again. So if I go back to second trace, intersect, this time I'm going over to the right side. And it may take you just a moment to be able to see your cursor. There it is. Enter, enter, enter. There's my second answer. After 7.72 seconds, that ball has come back down. Now it's at 35 feet again. And here's the thing. For this question, it's okay for me to have two answers because the ball was 35 feet in the air 2 different times. That's okay. So right there, you're done. That's the answer to your question. Alrighty. So our very last part of example A, it reads a little bit differently, and here's why. It says how high is the ball after 2 seconds. It doesn't give me a height. It gives me a time. And if you notice back at the very beginning, we said that time was x. And your calculator actually has an x equals button that you can use, so that's what we're going to look at now. So what I'm looking at here is, what is the height when x equals 2? So I don't have to retype the equation in my graphing calculator. It's already there. But this time, when I go look at my graphing calculator, I'm not going to choose second trace intersect. I'm going to go to second trace, and that first option there is value. I'm going to choose value. And if you notice when you choose value, it pops up a little blinking bar at the bottom of your screen that says x equals. You can type in any value there. So in this case, we want to know what happens when x is 2 after 2 seconds. Well, once I click enter, it tells me that after 2 seconds, the ball is 192 feet in the air. That's my answer. So I didn't have to do any mathing in my head. I didn't really have to do a whole lot in my calculator either. But one takeaway I want you to have from this video, if they give me a height, I'm going to y equals, because a height is a y value. It goes up and down. If they give me a time, though, time is an x. When I graph time, it goes left and right. Okay? So, and this is the new part for today. If you are given a time, you don't use second trace intersect. You use second trace that is all for today. If you would like the extra practice, you are welcome to do example B. But if you feel like you've got it, you are welcome to flip over to the back of the page and start practicing.